So now that we've wrapped up the distribution network and we have all of the points necessary for us to begin copying a crowd to, let us begin on the crowd. Now in our case, our crowd's pretty simple. It's just spheres. So the objective of this video is as follows. First, we're going to create our sphere geometry. Then we're going to create a couple of custom parameters, a minimum radius and a maximum radius. And then we're going to wire everything up so that our sphere geometry is copied around to all of the points created by our distribution part of the network. And then we'll make sure that we do some stamping and some very simple expression work so that we randomize our radii of each of the spheres between our minimum and our maximum radius set forth in the parameters by the artist himself. So that is the objective of this video. There's no reason to whiteboard anything out. Everything that we're about to do has been seen. Many of the things have been seen numerous times. So Steve, let's go ahead and get this show on the road.
Cool. So I'm going to bring everyone's attention down to the point in the network where we actually have our template points in a usable state. Because before we copy our columns, we only have a single column of points. Now we could branch off here and take our points and then copy the spheres to these points. But then we'd have a problem because we merge back in and our spheres would get scaled by our overall depth and height transform, which means they could be scaled differently in X and Z than they are in Y. So what I'm going to do is allow the points to be scaled so they still sit with our bleachers, but then branch off when we come to basically separate our points so we can copy our spheres to them and then merge them back in with our existing geometry. So this is going to be where we branch off to separate our points and our geometry and work with the points, but to do that we need to group our points. So I'm going to go right back up to where we have our line sop. And after we delete out our endpoints, I'm going to create a new group to group all of these points. So I'm going to right click and wire this into a group sop. Enter to accept, enter to drop this in. And let's name this something like group audience template. And the group name will be audience template group. We're going to be grouping points and we're going to group everyone. So that group's going to follow down all the way through our network so that when we get here and we've got our overall depth height transform, we can right click and wire in a delete sop. And let's name this to delete audience template. And on this delete we can delete out our audience template group as points, and that's going to remove them from our geometry so we have just our geometry on its own. And we've seen this technique before. We can middle click, branch off into another delete sop, which I'm going to name as isolate audience template. And on here we're going to again be deleting points. But instead of deleting our audience templates, we're going to delete everything except them. So now we have these points on their own in a state where we're able to copy spheres to them. So to do that, we need a sphere to copy. So I'm going to push tab to bring up the tab menu and drop a sphere into our network. So enter to accept that, enter to drop that into the network. And I'm going to rename this sphere to audience sphere. I'm going to set our audience sphere to be of a NURBS type. Let's push W to come into a shader view and space 1 to come back over to a perspective view. And let's bring up our construction grid. Fantastic. So we're going to have a NURBS type, and I want to offset in Y so that we sit up on the construction plane. So to do that, I'm going to set center Y to be our radius in Y. Wow, I'm just mashing the keyboard up here. That's crazy.
There we go.
There we go. Fantastic. Awesome.
And this means that now when we copy this to all of our points, our sphere is going to sit on top of the bench, not halfway through it.
Exactly. I also want to set it so we have perfect spheres, which means I'm going to make radius Y and radius Z reference radius X. Once we have this guy copied about, we're going to come back and control radius X using stamping so he's randomized for all of the points. So let's set rad Y to be equal to rad X parameter.
Okay.
And rad Z equal to rad X parameter, which means we now just have the single parameter to control for our overall radius.
Okay.
So I'm going to right click on the output of our audience sphere, wire this into a copy sop, and then we can take our points as our template. Let's just turn off the construction grid.
Okay.
So I'm going to right click and wire this into a copy sop. And I'm going to left click on the output of our templates and wire that into the right of the copy. We can already see spheres getting copied all over the place, and there are a few issues. Well, first I want to rename this to copy audience.
I see a sizing issue and an orientation issue.
Yep. The sizing issue, easy to fix for now. We can simply scale all these guys down by changing their radius, but look at that. The orientation's all over the place. We really want these spheres to sit on the bench in this orientation, not to be sitting on the bench so that they're rotated all over the place. And we've already seen that we can use basically the normals on the template geometry to affect the orientation. So let's add a point stop to create normals. And instead of leaving the normals set to their defaults of $nx, $ny, $nz, we can add a normal, we can zero these out. So we set all three of these to 0. The spheres now come in with whatever orientation they had down here. So we've sorted out the orientation, but we still got the radius issue to control, and we want to basically randomize the radii between a minimum and a maximum. To do that, we're going to need to create some parameters for the artist to have some control of. So I'm going to right click on the bleachers, come down to type properties off the bottom of the window. And inside our audience folder, I'm going to create 2 float parameters, one for our minimum radius and one for our maximum radius. So I'm going to name this to, let's think, something like, I guess min radius for the parameter. I'm trying to think of like a human name that would make sense. Min size?
Yeah, that sounds good.
As opposed to radius, just trying to keep with the keeping things as human readable as possible.
Yeah, I don't have a problem with that.
And let's call this max radius with a label of max size. I will lock both of these with a minimum of 0.001. And if we accept this, so on our copy audience, I'm going to come over to the stamp tab, check stamp inputs, and let's create a variable that's going to act as a random number that gets stamped up onto all of these guys. So let's just call this audience rand, and the value is going to be a random number driven by the point number, let's bring this up in the expression editor, driven by the point number, which obviously is different for each audience member. But let's also have control over this with a seed. Just throw this question out. Do you reckon we should use one of our existing seeds or create a new seed to control this?
Let's create a new seed.
Okay. So I'm gonna
just so that if an artist wanted to change the randomization of the radii of all of his different characters, if the only way he would do that if we were using seeds that already exist, it would be to change positions,
you could affect positions or how many there are. Okay.
Yeah.
So I'm going to just close this off. So currently we're just stamping a random number based on our point. Accept. Then let's bring up our type properties. And let's create another float. Let's create this underneath where we're dealing with sizes.
Sure.
Let's put it in the audience folder.
So size seed.
Size seed makes sense.
Yeah, right.
Size seed. And I'll lock this at 0.001 and unlocked at 100.
Nice.
Accept this. So let's jump back to, undo that. Jump back to our stamp parameter, and inside our random expression we're going to take our point number and multiply that in by our size seed, and then close off the random expression. So now our random number is going to be unique for each point and also controllable by our seed.
Now we can stamp that back up.
Fantastic. So on our sphere, on our radius x, we can take that number and we can stamp it back up to here. So that was on our copy audience, and it was the audience rand. I think I called it audience rand.
You called it audience rand.
We'll double check in a second.
Sure.
And default that to 0.
Okay. But in this particular case, we have a minimum radius and a maximum radius. And here we are left with a value that is going between 0 and 1.
Exactly. So now all we should see, if our stamp is successful, is spheres that range between 0 and 1. Then we can come back and take this and remap it between our minimum and maximum.
Sounds good.
So if I accept this, if all has gone well, and indeed they are randomized, so I'm guessing the stamp's working, we've got radii that vary between very small and up to 1. So let's take this, and we've seen how we can remap a value that comes in between 0 and 1. We can use the fit 0, 1 expression. This is our value we want to remap. And what do we want to remap it between? Well, we want to remap it between our minimum size and our maximum size. So let's grab our size, min radius up on our asset as our new minimum. And let's grab our max radius up on the asset as our new maximum, and then close off the fit 0, 1 expression. Now, if we accept it, it's going to look like everything broke, because currently these guys are set extremely small. We can come in here and we can say, okay, let's boost our max size up and our min size up. And now we have complete control over the sizes, which I will change the ranges, because currently we need to work with very small values because we're getting intersections. We also have control.
You could also just leave those ranges and multiply the result to scale it.
I like that, because then we're dealing with more room.
Yeah.
So yeah, that sounds cool. So I'm going to come into our stamp expression. Now that's something we haven't done yet, which is kind of cool. We can take our min radius, and let's take that and multiply it by 0.01. So we're only using 1% of that. And let's take our max radius and multiply that by 0.01. So we're only taking 1% of our max radius. Accept that. And bring our parameters back. So now our max size. Maybe that was too extreme.
Excellent, but that's good.
That's cool. So we can come back in and let's just take, say, 10% and accept. That's nicer. And zoom in. So now we can take our min size down and our max size down, and we can have complete control over the size of the audience members. Remembering, of course, that if we were to change our overall height and overall depth...
Let's go over to the bleachers and
Sure, that's not going to change the size of the audience. It's just going to change how spaced out the distribution is, which means that we could scale this up in such a way that we then need to come in and give large radius values.
Very true.
So we come over here, and we've got our height and depth parameters. So as we increase the height, you can see that it's increasing the spacing, but we're not scaling our points, our spheres.
Now let's do the depth.
And then the depth. Again, everything's spacing out. And with those really spaced out, we could then come in and really boost these up if we wanted to. Cool, so I'm going to undo back to this point. So we've got our sphere geometry for our audience being copied. And it's being, let's turn off points so things are nice and clean. And we're being, generating our radii randomly. So let's take this guy, and then we can merge him back in with our stadium geometry, and that will conclude this video. So I'm going to right click on the output of the delete, wire into a new merge, which I will rename to merge audience. And let's take our copy and wire that into merge audience. So now we've got our audience sitting on the stadium, which then if we had a floor object that wasn't at the origin, we'd also offset everybody in Y.
Nice.
Cool.
All right, and that's everything that we had set out to complete in this video. So that wraps up the video. Thanks a lot, guys.